Let's try to construct this matrix in Matlab and see if we can do that. So let's say n is equal to 8. Okay, m is equal to something a little bit different, 10 maybe. Okay, and we try to construct a big matrix in Matlab. How big should the matrix be? Huh? N square? N times m squared. It should be 80 by 80 matrix, right? And let's say dx equal to 0.1 and dy is equal to what? Let's say 0.01. Okay, so that we can see the difference. So, so the first we are going to matrix A equal to zeros, n times m. That makes 80 by 80 matrix, right? Okay, then first let's fill the diagonals. Okay, a of I and I is equal to minus 2 times 1 over dx square plus 1 over dy square. Okay, so now if you open up this matrix A, you're going to see I filled the diagonals to be minus 20200. That's what the diagonals are. Alright. Okay. So now the immediate up and lower diagonal. So that I'm going to do a double loop. I goes from 1 to n. For now j goes from 1 to, so let's say n. Oh, actually I want to do this. Let me do. So for I goes from 1 to n minus 1, because for each block I only need to fill n minus 1 entries. Okay, so I'm going to do a of I plus j times n. Actually j minus 1 times n, because I want the first one to start with 1, right? And I plus j minus 1 times n plus 1. That should be equal to 1 over delta x squared, right? Okay, and also let me copy this. The lower diagonal component of this plus 1 and this not plus 1 should also be equal to 1 over dx squared. Alright. You can see now we filled the lower and upper diagonal of this matrix, and you should also see a gap at which point? At this point, right? So you remember, like, we have the first line represented by the first 8 by 8 block of the matrix. So this is the first block, and the lower and upper diagonal discontinuous at this point. There is a gap here, and then the second block starts from over here up to 16, and there is another gap over here, right? Questions on that? The remaining task is to fill the diagonals that are n entries away. That I have I goes from 1 to n, and the j goes from 1 to n minus 1, and I have I plus j minus 1 times n. Now what is the second one? What is the j index? It's n entries away, right? So j times n is equal to 1 divided by delta y squared, and the a of I plus j times n, I plus j minus n, 1 times n, is equal to 1 over delta x, delta y squared. Alright. What happened? Oh yeah, okay. So now we filled here. This is the upper part, and we also filled here. And these two lines, they go all the way to the very end. there is no gap in this. And let's scroll to the very end of the matrix. Looks like this. Interesting thing is, if you spy the matrix, that basically looks at the sparsity pattern of the matrix. That's what it looks like. It clearly has these blocks, right? 8 by 8 blocks. There are 10 of these blocks on the diagonal. And each block has a tridiagonal structure, and there is each block has an upper block and lower block. All right, so that's our initial discussion on the two-dimensional finite difference, and we can start to use these matrices to solve different equations, which is what we are going to cover on Wednesday's lecture. Questions?
No, I have something to say.
Oh, you have something to say, so let's wait for Anshu to have something to say.
I updated the submission requirement for two updates. The first is that now all the files should be located in the root of your zip file. That's first. And the second is that now we do not collect any hard copies of your report. So that's through submission requirement update. So try to please just review